provisional. What you now know is provisional. It can change tomorrow. Like, for example, when I was an MBBS student, I learned that the #1 contraindication for beta blocker is heart failure. But now we know it is actually the #1 indication for beta blocker is heart failure. So knowledge changes depending on evidence that comes. So whatever you now know is subject to revision when confronted with new evidence. And the growth of scientific knowledge is predominantly incremental, which means you stand on the shoulders of your predecessors. You don't displace them. You stand on their shoulders and gain new knowledge. We build on past knowledge. That is what I said. We stand on the shoulders of our predecessors more often than we displace it. We add to our knowledge rather than displace the knowledge. So what is essential if science has to progress is that this knowledge has to be disseminated. This knowledge has to be disseminated among the scientific community. And that is the aim of scientific publication. The most important mechanism in use today for disseminating and preserving knowledge within the scientific community is a scientific presentation or a scientific publication. Now, before you start writing an article, decide on these things. Question number 1, should I be writing this article anyway? Of course, that is most important. First of all, you have to decide whether you really want to write this article. If you are half-hearted, don't proceed any further and stop there itself. Question 2, how will I find time? Because this is a time-consuming process, no doubt about it. Maybe you don't have to spend 1 week at a stretch for that, but you have to find some time every day, maybe 1 hour a day to write this article. So second important question is, do you have time? Will you be able to find time? Third, should I start writing what I can as soon as I can? This depends. Some people start writing as soon as they think of the project. Whereas there are other people who let the process digest in their brain or digest in their mind. And only when it gets solidified, they start writing. So it depends upon individual preference. You can start writing as soon as I think about writing an article, or you can wait till the idea has really formed in your mind. You have to definitely think about your co-authors, because you cannot have pulls from various directions. It is going to create a mess of your article. So definitely you have to decide who are your co-authors. And then, as you know, research is actually research. You are searching again and again, which means there is no end to it. So you will have to find a research question. What am I going to do with this article? And decide where you are going to stop. You will have to say, well, I stop here, but there are more things to be done. And what is the future? What are the future things that you can do in this field? So you should have an endpoint. Endpoint is actually the beginning of the next paper. Well, should you start with the title? The title is actually the most important part of the article, because only if the title is catchy, only if you can catch the reader's attraction by the title, can you expect the reader to go further down the lane. So title is definitely very important. So maybe you can start with the title, but then it should be in your mind that you are going to edit this title and make it more attractive. Title is very, very important. This is probably the first thing that you have to decide, which journal I am submitting to. Depending on what the topic is and what the journal's scope is, one has to decide to which journal you are submitting to. However good your article is, however scientifically strong your article is, if you send it to a journal whose scope does not include the topic on which you are writing the article, that will be rejected. So this is probably one of the first things to do. Decide which journal you are submitting to. And finally, of course, how should I define success? The only definition of success as far as an article is concerned is that it should get published. So that is easy to answer. You define success if it gets published in the journal of your choice, which possibly is a good journal, an indexed journal with a good impact factor. Now, what about a good writer? The best way to become a good writer is to become a good reader. It is said that the best way to become a good speaker, a conversationist, is to be a good listener. So here also it is the same. Best way to become a good writer is to become a good reader, because consciously or unconsciously, as you go on reading good scientific papers, you imbibe the style and approach which is found in these very best scientific papers. And finally, you also will be able to write a good scientific paper. It is not copy, it is not imbibing the style and approach of these scientific papers. So if you want to become a good scientific writer, first thing you have to do is to read a lot of good scientific papers. And then, of course, These are said by everybody. These are all important characters of a good paper. No needless words. Make it as precise as possible. What you have to say, you should say definitely. There should not be any confusion about what you are saying. Make definite assertions. Be very specific. Do not beat around the bush. Be what you want. Say what you want to say. Write what you want to say. So be specific, definite, and concrete. And of course, avoid fancy words so that the reader's attention is directed to what you want to say. And it does not go away to the fancy words that might be in your article. Now, a scientific publication is an important part in the career of any scientist. If you consider yourself as a scientist, even if, doctor also is a scientist after all. If you consider yourself as a scientist, an important part of your career is writing and publishing in a peer-reviewed publication. Well, you don't have to be a good writer to write a good science paper. If you are a good writer, that is superb, that adds to your quality. But what you require is actually a careful writer. What a scientific publication requires is not a good writer, but a careful writer. Good science writing does not require creative writing. It is not essential that you should have creative writing also. It is the quality of the science that is important. Most editors, most readers look at the quality of the science rather than the quality of the writing. When a reader does not understand what I have written, remember, it is almost always my fault, not theirs. So it is your duty to write it in such a way that the reader understands what you have written without spending much time. That is all the quality of writing that you need. Rest are all not actually required. Now, why write and publish a paper? It is important for two reasons. One of the reasons is altruism, which is a strong desire to contribute to the advancement of their field. You have wedded to that field. For example, I am wedded to cardiology. So naturally, if I can contribute even a small to the advancement of cardiology, that gives me a sense of satisfaction. That motivates me. So that is altruism, where there is no self-interest whatsoever. But after all, we are all human beings, and so we also have self-interest. So the second reason why you should publish a paper is self-interest, which are tangible benefits to the author. Your career may be advanced, you may get promotions, you may get monetary rewards, you may get paid for the article, you may get paid for patency, etc., etc. Right now, in most laboratories, most scientific communities, it is either publish or perish. You cannot really proceed further in a scientific field without publishing. So you should have self-interest and you should have also altruism. So it should be self-interest and altruism. It should not be self-interest or altruism. You should have a combination of both. And it should be finely balanced. Altruism and self-interest should be balanced. If your aim is only self-interest, for example, you will not be willing to do a replication experiment. Suppose there is a trial which shows that drug A is useful in disease B. Somebody has published the trial, but one trial is not enough. One sparrow does not make a summer. So you require more and more trials. They are known as replication experiments to prove that the group of drugs A are useful in the disease B. So this replication experiment actually do not give you much of credit. So if your only aim is self-interest, you will not be doing such studies. The same is true if you do a trial drug A for a disease B and you find that the drug A is not useful in drug B, you stop there if your interest is only self-interest. But if you are altruistic, you will still publish it because that gives the information, that gives the knowledge to the public that drug A should not be used in disease B. And then, of course, if you are purely self-interest, if your career is purely run by self-interest, there will be a lot of faddish, safe science. You don't really go for creative explorations. Feuds over priority. You will be competing rather than collaborating. Whereas science, after all, is a matter of collaboration. Should not have competition, but you should have collaboration. Transparency will be sacrificed. Disclosures will be sacrificed. And then, of course, there will be conflict of interest, double publication, plagiarism, outright fraud. So there should be a fine line where altruism and self-interest meet. In most of us, in most of even the best scientists, there is an element of altruism, there is an element of self-interest also. So as I said, it is altruism and self-interest, not altruism or self-interest. Well, coming to the presentation per se now. The three pillars of a good presentation are: one, accuracy. New knowledge claims are justifiable and verifiable. You should be accurate in what you are going to say. And you should also be sure that what you are saying could be justified, could be verified by other people who may not be even knowing you. So accuracy is one of the pillars of a good presentation. The second pillar is precision, which means what you say is understood by the reader also. Understood by the reader, meaning understood by the reader is exactly same as the meaning intended by the writer. So precision is the second pillar. And the third pillar I would say is clarity, which means the work is easily and quickly understood. Most readers have several other work to do, so you don't expect him to spend too much time on your presentation. So it should be precise, it should be clear also. Rereading a passage multiple times to get its meaning is only means that clarity is missing. So the reader should get the meaning by just reading the passage just once. Grace is good. As I said, if there is grace also in your writing, that is a bonus. That is an added point. But elegance, beauty, or charm, all of them are good, no doubt about that. But if it is at the cost of accuracy, precision, or clarity, it should be sacrificed. So the fundamental importance should be for accuracy, precision, and clarity. On top of that, if you can also write gracefully, that is fine. That is a bonus. That is good for your presentation. That writer does the most, who gives his reader the most knowledge and takes from him the least time. So that is what I was saying. You don't expect the reader to spend too much time on your article. So it should be clear and precise that the reader gets what you want him to know with the least time. Actually, that is more difficult. As President Roosevelt said, it takes about an hour to write a 1 hour speech, but it takes 2 hours if you want to do a 30-minute version. And if you want to do a 5-minute speech, maybe you will have to prepare for 2 weeks. So the shorter you are making your presentation, actually it is much, much harder. This was also said by the novelist Henry David Thoreau, who said, not that the story need be long, but it will take a long time to make it short. So short is sweet. Brevity is actually sweet, but it takes a lot of hard work. It is not that easy. And Mark Twain wrote, if I had more time, I would write shorter. So remember that short and sweet is always the principle of a scientific publication. Don't beat around the bush. Come to the point and make it clear and precise. Well, this is, I'm sure many of you who have interested in research would have heard of this finer criteria. Finer is the criteria to evaluate a research study. The first question is it feasible? Can you do the trial that you are about to encroach upon, about to embark upon? Is it feasible? Number two, is it interesting? If it is not interesting for you, don't expect other people to be interested in it. So is it interesting? Is there anything novel in that study, or is it all already discussed, already trialed, already studied point that you are again doing? Is it novel? And of course, most important is ethical. There are ethical standards above which you cannot go. And finally, is it relevant to the current knowledge? Has this knowledge already been there? Is it relevant to the knowledge? So these 5 questions has to be answered in the yes before you go further in making the research question. So I'm sure all these will be talked in the coming sessions in more detail, but just to give an idea about how you go about writing an article, the first is of course introduction. In the introduction, what you are going to say is what is known, our understanding of the world, and then you say about what is unknown, which means you are talking about the gap between the known and the unknown. And thirdly, in the introduction, you say how you are going to fill the gap. So you say what is known, you say what is unknown, and then you say how you are going to fill the gap. That is introduction. Then you go to the methods, which talks about what exactly you did in the trial or in the study, and the results are what results did you get. Finally, you discuss about how do the results fill the gap. So you come back to the introduction, you have said how and why we should fill the gap, and now we are talking about how the results fill the gap. And finally, you conclude, what does this mean for us going forward? What is this trial new into this world, and how can we go forward from the conclusions reached from this study? Now, the first thing that you do when you look upon a project, when you embark on a project, is to begin with the literature search. Because in the introduction, as I said, first thing what we have to know is how much we know. What is the state of our knowledge as far as this topic is concerned? Science is about either confirming or refuting existing knowledge or developing new knowledge. As I said in the introduction, There is a lot of knowledge existing. So you can either confirm the knowledge or you can have a skeptical questioning of this knowledge. Is it right? Is it time to change that knowledge, or is it time to change that opinion? Or you may be developing new knowledge. That is all science is about. So for that, you should know what is the present state of knowledge. A thorough understanding of the current state of knowledge is hence essential before you go forward. So remember, literature search is not about finding papers. It is about studying relevant papers, studying what has happened in that field. Suppose you are presenting an article on heart failure. The first thing will be to study on where we stand in heart failure now. What are the drugs that are available? How much of the pathophysiology of heart failure do we know now? And then look at what we do not know about heart failure. What are the gaps in our knowledge? What studies can we do to take our treatment of heart failure further, to take the knowledge about the pathophysiology of heart failure further? So studying relevant papers to know where we stand is the crux of literature search. Again, I'm sure this will be talked about subsequently several times, but just again to give you an introduction, you start with title, abstracts, and keywords. Make them easy for indexing and searching. Remember that the most widely read parts of your article will be the title and abstracts. That will be read by a lot of people. And only if your title is attractive, if your abstract is attractive, the reader will go to the next stage. And the next stage is otherwise known as IMRAD or IMRAD. This is the structure which most journals go about. That is introduction, methods, results, and discussion. Remember, journal space is not unlimited, so make it as concise as possible. And as I said, the time of your reader is not unlimited, so make it precise and clear. And finally, of course, conclusions, acknowledgements, references, and supplementary data. So this is the general structure of a research article wherever you are going to publish it. The title and abstract, let me once more re-emphasize, is very important because it is only from the title that the reader will go to the abstract. If the title itself is uninteresting, nobody is going to read the abstract. It is like reading a newspaper. You don't read the newspaper from the front page to the last page. You read the title. If the subject is of interest to you, you read the news. Otherwise, you go to the next news. So the title has to be interesting. If the title is interesting, you can expect the reader to read the abstract. And if the abstract is interesting, you can stimulate the reader to go further and read the paper. So title and abstract are very important. The abstract hence should contain everything. It is a standalone summary of whatever the paper has. It should include everything: background, motivation, context, aim, objective, approach, method, results, conclusions, implications. But at the same time, it is an abstract, so it has to be very short, and it should be concerned in maybe say 150 words or in one small paragraph. So writing an abstract, you should take a lot of time to write an abstract, for the simple reason that abstract is the one which the largest number of people are going to read as far as your paper is concerned. Tell a complete story in the abstract. The abstract is for most readers, remember, the only part of the paper that will reach. They will usually not go further down unless it is a subject in which they are really interested in. So make sure the abstract is perfect, the abstract is interesting. Now, when you decide to write, there are two types of writing that you can embark on. One is known as the free writing, and the other is known as generative writing. Let us talk about free writing. Now, when you decide you want to write something, you immediately start and write down and ensure you continue writing. This is only for you. The only person who will read your free writing is you. So you don't have to worry about spelling mistakes, grammar, linking, no problems. You are just writing what you feel on a paper or on the computer. A great way to get words on paper or computer. Now, once you have finished writing, once you have primed yourself, then you go to generative writing. Free writing exercise primes your mind for writing a more cohesive piece of work. But this generative writing is for the reader, for the editor, for others. And so spelling mistakes should not be there, grammar should be correct, linking should be fine. So you start with free writing, and when you are confident, then you go to generative writing. You are writing, generative writing is in anticipation of an audience. This can be the editor who will decide whether it will publish or not, or it can be the general readership also. So we have, to sum up what I have so far said, we have introduction, methods, and results. Introduction, what did you or others do? So far, what has been done? And why you are going to do what you are going to do. Methods is how did you do it, and result is, of course, what did you find. A good introduction should answer the following questions. What is the problem to be solved? Is there any existing solutions? Which is the best solution so far that is known? And what are its main limitations? And what do you hope to achieve by this article? So you find out the problem, look at the existing solutions, see whether these solutions are enough, are there limitations in these solutions, and then you decide about your own solution and try to achieve a better solution than what is already there. So what and so what should be the answer, should be the question when you write an introduction. Make clear what research questions this paper is trying to answer, because in an article you don't write about research questions, but by the time the introduction is over, the reader should understand what is the research question. Materials and methods is possibly the least read part of your paper. Most people don't read it. After the abstract introduction, they go to the discussion. But this is the most important part as far as the editor of a journal is concerned. It is based on this that the editor is going to decide whether she or he is going to publish the article. If the methodology is correct, whatever the results are, the journal is going to publish it. Whereas if the methodology is weak, if the methodology is faulty, then your article is not going to be published. Whatever the scientific results are, how beautifully you have written the article doesn't matter. The methodology is important. Moreover, people working in the same field who want to do the study again or who want to follow the same pathways will be reading materials and methods. So materials and methods are possibly the least read by the general audience, but they are read by the most important people. I would say like that. Materials and methods are not read by many, but those who read materials and methods are the most important people, especially the editor who is going to publish it. So the materials and methods should be sufficiently detailed so that an independent researcher working in the same field could reproduce the results sufficiently to allow validation of conclusions. So the methodology tells the editor that this is a good trial. This can be replicated. This can be validated. This will, of course, you are going to say about what was done and how it was done. And finally, you should be able to justify the experimental design, including possibly justify if there are any faults in the experimental design. And of course, the method that is chosen, why you have chosen this method. So materials and methods are most important if you want to get the article published. Now coming to discussion, in discussion, one of the important things is that make sure that you have a lot of figures, because a figure is worth 1,000 words. Maybe you can get a lot of information with a figure. Again, when a person who is not very interested in your topic scans through your discussion, what you will be looking at is the figures, because you get lots of information from the figures. So figures should be there and they should be perfect. Illustrations, including figures and tables, are the most efficient way to present your results. Your data, is the driving force of the paper. And this data can be given in figures and tables, which will catch the eye of the reader and the editor also. So illustrations are critical. Graphics are important. They can be used to explain and clarify. But remember, if not properly done, it will also confuse or deceive. So make sure the graphics explain what they are supposed to explain. The first rule of graphics is a simple one. They must help to reveal truth. So it is like writing only. It is like what you write in the prose. It should reveal the truth and it should be precise and it should be very clear. It should document the data. It should make comparisons. It should allow for inferences for cause and effect. It should tell a story and should integrate with the text to enhance the overall communication. So figures and tables do a lot of things, but it has to be carefully made, and you make sure that whatever I have written here, document the data, make comparisons, allow for inferences, telling a story, and integrate with the text. All these criteria are satisfied. So these questions has to be answered. Are you really sure that the graph is showing the truth? Is the representation accurate? Are the data carefully documented? Has there been any faults in the documentation? Does it show any spurious readings of the data? Appropriate comparisons and contexts are shown. the right data to display? Is there any uncertainty in the data that is to be properly assessed? And finally, can others validate your conclusions? Always be reader-centric. Think about how the reader is going to approach your graph. If a reader, you know what you are writing about, but the reader does not know what you are writing about. So for the reader at a single vision, single look, can he say that it is the truth, it is accurately represented, it is carefully documented, and there is no spurious readings, and it compares the context as shown? So that is very important. What will you put? Tables or figures? It's a general. In general, the principle is that tables give the results, whereas figures are used to compare. Used for comparison of experimental results, maybe with previous works, maybe with your own works, maybe with calculated theoretical values. Figures and tables must have legends. You should write under the table what exactly you mean by this figure and table. So they should be self-explanatory. They should be standalone, just one figure or one table. You don't have to read the text. It should tell you what exactly you are meaning by this figure and table. As you can see here, this is a table which you can see shows several values. The same thing you can put it in a figure, and you can see there is comparison with colors. You can see with various colors you are comparing various columns, 1, 2, 3, 4, 5. On the right side, they are compared with colored bar diagrams. Avoid crowded plots. The principle in scientific writing always is be clear. Don't make the reader, don't put the reader into trouble. So avoid crowded plots. Just put only 3 or 4 data sets figure. You can have 2 or 3 figures, but don't put everything into one figure. It will create only more complicated. Think about the appropriate axis label size. You have an x-axis and a y-axis. So put the label clearly so that there is no confusion for the reader. And the symbols and data sets must also be easy to distinguish. Never include long, boring tables. Nobody is going to read all these long, boring tables. So be short and give the data that you want to give. So data, figures and diagrams are not for checking your eye. They are not eye charts. Make them large enough to reach. And when you put figures, again, 1 out of 2 and 50%, there is a lot of differences. So when there is a small sample, write 1 out of 2 rather than 50%, because that gives a lot of wrong impression to the reader. Well, we now come to discussion. In the discussion, you are comparing the published results by your colleagues with yours. So here you are comparing your results with the results that has come before your trial. That is the published results. Now make sure that you don't ignore a work just because the results of that work is opposite to yours. Never ignore the work in disagreement with yours. On the other hand, confront it and convince the reader that you are correct or better. That will be a better strategy than ignoring the work that is in disagreement with you. Avoid non-specific expressions, higher temperature, lower rate, highly significant. These are not used in science. Use specific values, 35 degrees centigrade, 0.5%, etc. So quantitative descriptions rather than unscientific expressions will create value in the discussion. The reader will know that you are very specific and you know what you are talking about. And finally, coming to conclusion. Conclusion again is one of the most widely read part of your article. Most people who are not very interested after reading the title and abstract will go to the conclusion to find out what exactly you have found of this. This should be a brief summary of the results and discussion. It should be reader focused. In one paragraph, the reader should understand what you have found out from your study. Allow for opportunistic reading, which means it is again standalone. You can only read the conclusion and get an idea about what this whole paper is about. Concisely provide the key messages the author wished to convey, and also give a final and most general conclusions and what the future holds for. That is also very good. From here, from this work, where are you going further? Where are the other research workers? What suggestions do you have for the other workers as a future? In the future to go about. So all these should be there in the conclusion. Remember that summary and conclusion are different. Summary means you are giving a summary of whatever you have done, materials, methods, etc., review of literature, everything. But conclusion is not that. Conclusion, you are only giving what you conclude from the study. These are my conclusions from the study, and of course, a future perspective and where I wish to go further from here after this trial. Now, what do you do if you get rejected? A better term will be declined to publish. The most important reason why most of the articles getting rejected, as I said earlier, is because the journal's scope and your topic are different. So most often it is you are submitting to a wrong journal. Topic does not match the scope of the journal. Or maybe because the quality of work is not enough, or the quality of reporting is not good. If it is the quality of reporting that is bad, it is good, because then you can correct it. It is much easier to correct the quality of the reporting. But if it is the quality of the work or the quality of science that is faulty, then it is really difficult. It is much easier to fix quality of reporting, a faulty presentation, than to fix quality of work, which means faulty science. So faulty work is easy, but faulty science is not very easy. And of course, the editors look on whether there is something new to be worthy of publication. Is it really significant? All these will depend on the editor as well as the reader. The significance should be just judged based on the viewpoint of the readers. How many people are going to read this paper? If it is novel, if it is something new, if it is worthy, then more people will read. And that is exactly what the editor is going to look at in your article. Do not succumb to temptations to send your article to different journals. Well, if one journal rejects it, I will send to another journal. So why not send it together to various journals? In fact, most journals do not consider a submission if they know that you have already submitted it elsewhere. And the attempts to improve your chance through multiple submissions is considered unethical. If the editors come to know of it, all of them are going to reject it. So it is unethical to submit your manuscript to multiple journals at the same time. The goal of scientific research is publication. As I said in the beginning, what is the success of your work? The success is its publication. A scientific experiment, it doesn't matter how spectacular the results are, how beautifully you have written it, it is not complete until the results are published. So publication is definitely very important. The goal of scientific research is publication. A word about null result, which I already said in the beginning. A null result means if you do a trial on the effects of drug A on drug B, you want drug A to be beneficial in drug B, but unfortunately you find that drug A is not useful in drug B, so you don't publish the result. That is the null result. Now, this is otherwise known as the negative result, but actually it is not a negative result. This trial tells you that drug A is not effective in drug B. So if you publish this article, many other people will not have to do the trial again to find out that drug A is negative or is not useful in drug B. But sometimes it happens that is known as the null result bias. People do not publish it, people do not send it. Science should be neutral to the answer. No is just as good as an answer as yes. So drug A is good in condition B is a good answer. Drug A is not useful in condition B is also equally good answer. Human nature, unfortunately, is not that way. You want an effect. You want to see that the drug A is beneficial in drug B. It does not usually happen. The only failed paper, actually, the only failed experiment when you cannot reach a conclusion. Now, this can have far-reaching implications. When the trials which show that drug A is not useful in drug B is not published, because several trials, like suppose a company develops a drug A, he does 10 studies and 9 of them shows that drug A is not useful in drug B, in condition B. But one trial shows that drug A is useful in drug B, and only that trial gets published. You know how much wrong impression it gives to the people, because the people do not read the other 9 trials which have not been published at all. This has happened in various fields of medicine, including cardiology. So the undesired conclusion is not a failure. You should not be dissatisfied or disappointed with the null result. Sometimes there is publication bias also. Editors also do not publish it, but most of the editors now know that if the methodology is correct, that is most important. If you have done the study properly, with a good method, then the result, whatever it is a result, and that is a good result. It is a wasted effort, because I said many people will continue to do the same trial because they do not know that the null result trial is already there. If readers remain unaware of these negative results, they are more likely to repeat these experiments in their own efforts to find positive results. So it increases the likelihood that the published results are wrong. As I said, one study is published showing that the drug is good in one trial, but all the other studies which are negative are not published. This happened with one diabetic drug, which showed that it increases the incidence of heart failure in diabetic patients. So there were a lot of trials which did not get published because the drug was not good in coronary artery disease. And subsequently it was found, so many trials have to go around till it was found that this drug, daughter known as glitazones, should not be used in patients with coronary artery disease. So you can see the wasted effort that happens because the null results are not published. So to conclude my talk, I will say that the first thing that you should do is to stick to the accepted structured format, the IMRAD, introduction, materials and methods, results and discussion. That is accepted in most journals, so go by the structured format. I would say these are the three pillars of a good presentation or a good scientific publication. Accuracy, clarity and precision are the three pillars of a good publication. But at the same time, these pillars has to stay on a foundation. Pillars do not stay on their own. So the foundation is probably integrity and honesty. Scientific honesty and professional integrity are a must if you want to go forward in publication. So honesty and integrity are the foundation stones, whereas accuracy, clarity and precision are the pillars on which a good publication stands. Remember that title, abstract and conclusions will be the most widely read parts of your article. And it goes in a line. You read the title. If it is interesting, you go to the abstract. If that is also interesting, you go to the conclusion. And if you find that also interesting, probably you will read the results and discussion also. Materials and methods are not read by many people, but it is read by people who matter. Materials and methods decide whether it will be published. The editor, serious writers who want to do further trials based on your study are going to read materials and methods. So make sure that is also perfect. But it will be the least read part. Always be reader-centric. Always look from the other side. You are a writer, but look from the other side. How is the reader? If I am the reader, what am I going to feel by reading your article? Am I going to get bored? Do I have to read it multiple times to understand what exactly you want me to know? Are you confusing me, or are you being accurate, clear, and precise? So that is probably the most important thing, to be reader-centric. And most editors also go by that, whether the article is reader-centric or not. I conclude here. Thank you very much. And if you have any comments or questions, you are always welcome. Any comments, questions?
Yes, sir. Excuse me, sir.
Yeah, please, you are audible.
Yes, sir. So you told about the null result and the negative results. Sir, is it the same or is there a difference between the two?
Null result and negative result are the same. Your research question, you ask a research question, is this going to happen if A plus B is equal to C or not? If you get a result that A plus B is not C but D, that is also an answer. So negative result is not really negative, it is a positive answer, but it is opposite to what you thought when you began writing the article. That doesn't matter. After all, knowledge need not always follow what you think. That is the basic of science. So that doesn't matter.
So, sir, if we get a negative result, then should we go for publishing? Should we try publishing? Or? Okay.
You should definitely try to publish. The only negative result is actually inconclusive. If you are not able to say either this way or that way, then of course it is an inconclusive result. That's a failed experiment. But all the trials are successful trials. The research question need not be answered in yes always.
Okay, thank you, sir.
Yes is also correct for a negative answer. Dr. Varghese is
journal for negative results.
Journal for negative results also is there. Okay.
Thank you, sir. Sir, we have another question by Aisha Jalil.
Hello.
Yeah, please.
So the question is, sir, I would like to know about how to prepare a title. What all should be included in the title?
I'm sure that will come in the courses to come. Or is it going to come or not, about how to write a title? What all should be in the title? Okay, as I said, the title should tell you clearly about what is going to be done in this particular trial. But at the same time, if it is a very long title, it may not catch the reader's eye. So it has to be a balance between, it should be short, but at the same time, it should tell everything. It should tell what exactly you are going to do in the trial. So the unexpected, the unknown reader should know what you are going to go about in this trial, what you are going to do in this study that you are going to continue. Writing a title should many times be left to the last, because you can again modify it and come out with a good title.
Thank you, sir. We have another question too in the chat box, and Sandeep Sunil has asked a question. Sir, what is the difference between introduction and an abstract?
See, an abstract is telling you everything about this article. By reading an abstract, you will know what was the introduction, what was the aim, what was done, and what was the result. Everything will be there in the abstract. But in the introduction, you are not talking about what you have done or what the results are. In the introduction, you are only setting the scene for why you are going to do about this trial. So introduction tells you only what is the state of knowledge now, what you want to add to the state of knowledge that already exists. Whereas abstract tells you everything. It tells about why you are doing it, it tells about what you have done, and it also tells about what results you have got and what conclusions you have got. So they are totally different. They are not the same.
Thank you, sir. And we have another question too by, hello Niranjana, are you asking?
Yeah,
okay, sir. I'll
I think
continue.
I can see the answer. What could be the smallest sample size for a survey? Is that the question?
Yes, sir. Yes, sir.
Yeah. What could be the sample size for a survey? For example, if we are to target a smaller population such as government veterinarians in a district, the population will be around 40 to 50 depending on the district. So could we design a survey with a sample size of 30? It is a statistical question. I don't think I will be able to answer you that offhand. I think you will have to get the help of a statistician to see what is the power of the study, whether that will be enough. And it also depends upon what exactly are you going to study. So I will not be able to answer that question.
Okay, sir.
If we obtain a null result, are you supposed to change the title and abstract of a study? Soumya Johnson, definitely not. You cannot change the title and you cannot change the abstract. You can have the same title and have the same abstract and then say the result is not unfortunately, fortunately or unfortunately doesn't matter in science. Result is a result. So you can very well say after the results we find that it does not conform to what we thought earlier. How should I choose a good platform to disclose my research paper?
Yes, sir. We have another question. Yes.
Yeah, Malavika Vijayan. I suppose good platform, you mean a good journal. Is that what you mean? A good platform to disclose my research paper? If it is a good journal, as I said, it requires some work. You have to make sure that your topic and the scope of the journal are the same. So you'll have to do some research. You'll have to read some journals and find out what exactly is the scope of that journal. What exactly is the readership of that journal, and then publish it in that journal. The next question I can see is Neha Shibu.
Could you suggest, we could read at UG.
Yeah, please. Could you suggest a few works journals we could read at UG level to get a better idea about writing papers? I think what you have to do is, there are standard journals like say New England Journal of Medicine or Lancet. What you have to do is to select the work that you will understand. Don't go into very hi-fi subjects, very hi-fi cardiology, for example. You may not understand it. But even these big journals, even these supposedly hi-fi journals, publish articles which are down to earth, which are understood even by an undergraduate student. So I think you should go for standard journals rather than looking at substandard journals. Then your standard also will be substandard. As I said, the more you read good journals and good articles, you will imbibe the technique of writing a good article. So select the article. Don't go for hi-fi articles, but select the article which you think you understand, which you can understand, and which you can possibly write also. Jasia Jabin has written, while publishing a paper, does the number of references used affect the paper getting published or not? Which is preferred, more number of references or less? I don't think it is either more number or less. It is the right number. Whatever you have quoted, whatever the knowledge that you have quoted, you should have a reference for that. If you don't write a reference, it is plagiarism. So it doesn't matter whether the reference number is more or less. What is needed is that whatever you have said in your article should have a reference. You should have quoted, you should be giving credit to the knowledge that is already existing. So there is nothing like more references or less references. And then I think Vinayak Prakash has written, on what basis should we choose a journal? And also, isn't it better if we go for another journal of the prior doesn't appreciate your work? Well, if a journal declines to publish your article, you are fine in submitting it to another journal. There is no doubt about that. But don't send to both journals simultaneously. That is unethical. So you choose the journal, you send to the journal. If they do not accept it, you are within your rights to send to another journal. And most of the time, the journal which has declined your article would give you a letter saying why they have declined. The peer review will be there about what points they are finding against publication. So maybe you can correct all those and send it to another journal so that the chances of getting it published becomes higher. So actually that is again, rejecting a paper or declining to publish a paper is also a learning process. You learn why they have declined your paper. So you can definitely make it better to send it to another journal, which fortunately might publish it also. Gauri Krishna says, what is the null result is different from the title and the readers don't go through the whole of the article. Won't my article be propagating wrong information there? So I think the title does not matter, but the abstract where also you have given the result, abstract should be changed. The abstract also includes the result. So the abstract should tell what the result is. That way I think you can circumvent that problem. Most good journals ask for publishing charts. Is there good journals without that? No, most good journals do not ask for publishing charts. Journals are divided into two groups. One are open access journals, where the subscriber also do not pay for the journals. So somebody has to pay, and so obviously the author has to pay. Whereas subscription journals like say New England Journal of Medicine or Lancet, you have to pay to subscribe to the journal. So the reader pays for the journal, whereas in open access journal, the writer pays for the journal. The writer or the author pays for the journal. Someone has to pay for the journal, that is very sure. So it is only question of whether it is a reader or the writer who should pay for the journal. So there are good journals which are open access. There are good journals which are not subscription also. Ruben Richards, can you please say if there is any research opportunity other than ICMR STS for an MBBS? I'm sure our JCMR will help you in that. You can meet the people in the JCMR. They will definitely help you to find out more opportunities. Yesterday's talk was about that. Okay, Vasudevan sir's talk was about that.
Is there any more questions from the participants?
What is an index journal and how do we know if a journal is indexed? No, indexing can be done in various things. Like say it can be indexed in PubMed, it can be indexed in Copernicus. So various journals get indexed to various, what do you call it? It's not actually institutions. What is the exact term for that? Indexed in databases, right? So you go to the, most journals will say that we are indexed in this databases. That is the only way. So the more an article is indexed, the more a journal is indexed, your article is likely to figure in a search, in a word search, in any of these databases. So if you publish an article in a journal which is indexed in multiple search engines, your article will have will be more widely read, will come more widely in a search engine. When somebody searches for, say, hypertension, if your article is published in New England Journal of Medicine, it will come, immediately it will come. Whereas if you publish in a much less known journal on hypertension, if you search in PubMed, it may not come there. If you search in Copernicus, it may not come there. So the more indexed a journal is, the more likely that your article will be read by more number of people.
Hello, so I think everyone has...
We can finish.
Wind up the session.
Yeah.
Okay, thank you. I hope we have learned something from this 1 hour.